looking at the NTP klib. If you're coming from Linux, you might be used to using NTP daemon to keep your time across various instances. And so this provides similar functionality. We'll just show you how it works. So let's look at our program here. So pretty simple Go program. We just loop through about 10 iterations and we print out the time. We wait about 8 seconds, and I'll explain why here in a second in between iterations. Let's look at the config. So the config, what we do is we paste in the NTP into our klibs array. Basically tells ops, hey, we want to include this. This is optional. It doesn't come by default. It's really only for people who want it. So that's why you need to put it in. This manifest pass-through. These are some options. A manifest pass-through is a nice little config tool where you can just pass all sorts of arbitrary config into Nanos. So NTP servers, we're just going to set it as this US pool 1, port 123. Now we're operating over UDP, so keep that in mind. If you're in a different part of the world, you can go to the NTP's website and get a closer location. If you're trying to communicate with a server that's really far away, you might not get all the packets, and it might take longer for your clock to adjust. So and UDP is unreliable to begin with. So just keep all that in mind and choose a server that's closest to you. Then we have NTP poll min and NTP poll max. So basically what this is these are the thresholds, the min and max thresholds that we want to pull NTP for. Now, this implementation of NTP that we coded up for Nanos, it requires a minimum of 2 polling events to actually start adjusting time. So you need to keep that in mind when you're adjusting these limits. We think 4 or 6 is fine, but just realize that it could take like 2 iterations of that 4 to actually adjust, right? So in this, and by the way, these are powers of 2. So 2 to the 4 is 16. 2 to the 6. So just keep that in mind. All right, so I'm going to show you what this program looks like just normally running, and we're just going to have it sit here and listen. We don't even need this port because we're not actually doing anything. All right, so this is what it looks like normally, and this is more or less the correct time. Maybe it's off a little bit, but this is more or less the correct time, right? How would you actually go about testing this, right? Like you deployed it, and now you want to, maybe ensure that it's actually working. Well, there's a quick little tip I can show you, and there's a couple of ways of doing this. One, I'm not aware of being able to set the time to the system manually in Go. I don't think there's an API for that. You would have to invoke a syscall there. You can do this in C, use set time of day. But in Go, I don't even think they have a API for it. All right, so this is what it is doing normally. Now I'll show you a tip. We're just going to look for the QEMU process. I only have one running, and we can go ahead and kill this. So this is the actual QEMU instantiation that ops ran. So if you're not familiar, ops is using QEMU when ran locally. Now, if you're running on Google or Amazon, it does not do this. It passes it off to the cloud, and the cloud does it for you. And there's very good reasons for that. But what we can do to test stuff out is we just cut and paste this, right? And QEMU has this little feature where you can set the clock. So we're going to do RTC base, and we'll just pick, from earlier last year, I guess. And we'll set the clock to the VM. And so basically this just says, hey, I want a different time. And as you can see, when we pop it up, it's pretending that that's the correct time. Now, like I said, this will take up to 60, 70 seconds before it actually adjusts. And that's because it needs multiple samples from the NTP server to actually adjust. So while we are waiting for that to adjust, we can go over some of these other properties, some of these other configs. So NTP servers, as we just mentioned, you can paste in that stuff. We support IPv4 and IPv6. We can support multiple servers, so just in case one is down for whatever reason, you have that. We went over min and max. NTP reset threshold. So this is interesting. This is basically a Boolean, and basically it says, do we either want to support step jump or smearing? So smearing is basically the practice where it slowly adjusts over time. It's not going to immediately adjust. And there's reasons for that, because if your software kind of depends on the clock not jumping hours, or in this case, a full year ahead, you really don't want that, right? But there's another way of doing it where you do a jump, and that's like the clock is so horribly off that you do want it to jump, and you don't really care about the consequences. There's caveats for this, right? So it's not like a one size fits all. In different situations, you might want to use different configs. And then these last two are slightly technical. You have your max slew ppm and your max frequency ppm. So I wouldn't really worry about that. That's really, these are more for debugging and so forth, or like super advanced. Let's swing back and let's just see how our clock is. Okay, so it already exited too. But as you can see, right here, we had it from last year, and then we jumped into the new year, Back to the Future style. So that's a pretty simple way of configuring your NTP, and then also by being able to verify that it's actually working. All right, so till next time, bye.